Hello, dear students. Welcome to the channel and welcome to this playlist in which we are discussing about sampling and reconstruction. And In previous classes, we have discussed about sampling theorem, what is sampling procedure, how sampling takes place. We have discussed about interpolation. We have discussed about different types of interpolation like linear or first order hold and zero order interpolation. Um, we've also discussed about the aliasing in the very last video. In that, we have seen what is aliasing, how it is hazardous or how it is harmful for my original signal, and how we can eliminate the aliasing effect. And later on, we saw the A to D conversion. And by the way, we also saw reconstruction of my original signal with the help of low pass filters as well. So last topic we discussed was A to D conversion, and today's class is going to be in continuation of that class. So if you haven't checked out previous videos, please check out the previous videos. The link will be flashing on the top right hand side corner of your screen in the I button. Just click on it and you will be there. And once you're done with them, then let's start today's class, which is about quantization. So when we discussed about A to D conversion, we discussed about three different steps. Remember, sampler, quantizer, and encoder. So the sampling and encoding process was very clear to us, but I told you that quantization or the process of quantizer is little bit different from it because it is not reversible, and I was going to explain it into the next lecture. So today I'm going to explain it to you. So what is actually quantization? So the definition is given here. As you can see, the quantization is a process of approximating or rounding off a sample value to the nearest predetermined level, which is also known as quantization level, right? And this whole process is known as quantization process, right? The sampled signal in my A to D converter is after sampling, it is applied to the quantizer block. And what does quantizer block does? So this quantizer block will convert my sample signal into the approximated quantized signal, which consists only which consists only predefined voltage levels, right? Which consists only finite number of predefined voltage levels. I think I have made some mistake in the writing here. There is no pre-aliasing here. Discuss about the only finite number of pre-aliasing voltage. It can be voltage or it can be any signal which you are actually discussing about. Not necessarily need to be voltage, it can be any signal. Every signal can be quantized. So each sample value at the input of my quantizer is approximated or rounded off to a nearest standard predefined voltage or nearest standard predefined value of whatever that signal is. And this standard level is known as quantizer level or or quantization level. Now see this image. In this image I'm going to explain to you the quantization. So you can see that my input signal is x of t, right? This is my this signal. This whole signal here is my input signal x of t. All right. Now um we are assuming it has peak to peak swing of voltage VL to VH, right? Peak to peak swing VL to VH. Now the entire voltage range has been divided in 7 Qs, actually 8 Qs, not 7, right? 8 Q levels like Q0, Q1, Q3 up to Q7, and uh, each of this interval has size s, right? They are divided in equal sizes, so each of this interval have size s. Now this s is known as the step size, and its value can be given using this formula: s is equals to vh minus vl divided by q, right? It can be given by vh minus vl divided by q. And what will be the value of q referring this figure? See how many sections we have. Total 8 sections, so q will be 8. Now at the center of these ranges, the quantization levels are placed in q0 to q7, and then we define them using delta 0 to delta 7. These numbers of quantization level, total number is 8. The quantization levels are also known as the decision threshold as well. Okay, so don't get confused when I say decision levels instead of quantization levels. Now this xq of t, as you can see here, I'm having a quantized signal xq of t. It is representing the quantized version of my original signal. Original was x of t, and we are getting xq of t at the output of my quantization, or output of the quantizer, right? After that the encoding process takes place. But right now we are talking about quantization, so let's stay on the quantization. So when x of t is in the range of delta 0, then corresponding to any value of x of t, the output of that quantizer value will always be equal to q0, right? See, for all these values, what is the value of uh, quantized signal? See, just q0, right? Similarly, for all the values on q1, the value will be uh, this much, right? So for all the values of x of t in the range of delta 1, the quantized output will be constant, and that would be q1. Same you can go for all the values of x of t in the q3 equal to delta 3, and delta 2 for q2, right? So thus in each range of delta 0 to delta 7, the my original signal x of t can be rounded off to a nearest quantization level, and the quantized signal is finally gets produced, right? Now the quantized signal has been produced, then what basically it is an approximated signal, right? We are taking approximation, and the difference between this approximation and original is an error. I'm going to discuss about it as well, but uh, this error, this error which I was just talked about, that error between my original input signal and quantized error should be as small as possible. And in order to minimize the quantization error, we need to reduce the step size by increasing number of quantization level, right? Because more the number of quantization levels you take, like you if I would take 70 levels here, then the size of the s will be way too smaller, right? Way too smaller. So my output wave would be more smoother, way more smoother than the 7 level quantization, right? So in order to get a smooth output, we have to take more quantization levels. Now again, what is the difference between the instantaneous value of the quantized signal and input signal? Basically it is error or noise, quantization error or quantization noise, right? And in this image here, the shaded portion is actually quantization error here. See the shaded portion over here, that is the quantization error. And the maximum value of quantization error can be plus or minus s by 2, because q0 is in the middle of the s, so it can maximum go till s by 2. After that the new quantization level gets started, and because of that we will not be able to consider it, right, in that level only. Now because of that we can reduce the quantization error, and we can have the reduced step size by increasing the number of quantization levels, right. Now let's discuss about discrete time processing of continuous time signal. First, you all may aware about maybe aware about continuous time signal and discrete time signal, and you all may aware about continuous time systems and discrete time systems. But let me tell you, basically continuous time system is defined as the system which processes my original continuous time signals and produces another continuous time signals as its output. And there is in discrete time system as well. So what is discrete time system? Just like continuous time signal, it is a system defined as the system which processes the discrete time signal and produces another discrete time signal at its output, right, just like continuous time signal. Now what happens, actually in certain applications the signal which we require to process are analog signals, but the system of that analog signal is a discrete time system. So in such situation we need to carry out the discrete time processing of continuous time signal, right. So see the first block diagram here. So it is showing you the block diagram of a system which processes continuous time signal using the discrete time system, right. So here what are you feeding uh, feeding your system as an input? It is basically continuous time signal, right. So first what would we do? We will first convert this continuous time signal into discrete time signal, right. So we are having this block which convert my continuous time signal into discrete time signal, and then we can feed it to the discrete time system, right, because the discrete time system will only accept the discrete time input. So then this the discrete time signal is processed and converted back to my continuous time signal. Okay, so discrete time signal which we have sent to this system will be processed under this system, and we will get an output in the discrete time system as discrete time signal as well. And again we will convert this discrete time signal into its original form, which was actually the continuous time signal. So again we will convert this discrete time signal into continuous time signal. So the output we will be getting will be the processed continuous time signal, right. So in many applications it is advantageous to do this type of discrete time processing for continuous time signals, right. And we can implement this type of processing using general specific computers designed for discrete time signal processing. Most of the computers are designed for discrete time signal processing, right. We discussed about it many times. So this discrete time processing of continuous time signals can be in the three steps. As you can see, the first one is the conversion of continuous signal to the discrete signal. The second one is to is to pass the discrete time signal through the discrete time system. And the third one is the processed discrete time signal to convert it back to the continuous time signal, right. So the continuous time signal, uh, and I'm talking about my original signal x of t, it is sampled at some sufficient rate of conversion in order to generate my discrete time signal, right. And then it is processed by discrete time system when we convert it into discrete time signal. And then the processed discrete time signal will be this much y delta of n, and we will convert this signal back to my continuous time signal. So the continuous time signal is converted into discrete time signal, with the help of sampling process. Of course, we discussed about it earlier. And then the x and t of s, which is basically a discrete time signal, are the samples of x of t taken at a regular intervals. So that you are seeing here, right? So the first block, this one, this one, is converting my original signal to x delta of n, basically continuous to discrete time conversion, which is known as C to D conversion. Third block is also performing exactly opposite or what first block has performed, right? It is converting discrete to continuous. So it is known as D to C operation or D to C converter. And in the digital computers and other number of digital systems, the C to D conversion is called analog to digital conversion. And for that, the converter we use is known as A to D converter. And there is a device which is used for implementation of D to C conversion. These devices are often known as D to A converters or digital to analog converters. So that is the discrete time processing of your continuous time signal. Sometimes you need to do it, but it's pretty much fair simple. Next, we want to discuss about is what are the different applications of signal and systems. Now that we have discussed about almost not, I cannot say we have discussed about every aspect of signal and system, but we have covered most of the basics. So after covering most of the basics of signals and system, now there is a time to discuss where we can use my signals and systems, where I can implement this type of logic. So mainly there are 3 to 4 areas when we can implement the logic and we can uh, get outputs, we can get systems working with the use of signal and system. First one is the control systems. So if we had as a subject known as the control system theory or control system engineering, you might have some idea about it. If not, no need to worry, I will be explaining it. Then we use it in the communication, not person to person communication, but uh, device to device communication or person to device communication. Then in the signal processing, and we all are well aware of different kind of signal processing, right? We all have done speech recognition or text to text to speech signal, so that is signal processing. And then audio signal processing, which is basically, can you can call it how you can create music or how you can differentiate two different type of audio signals. That is audio signal processing. First one, let's talk about first one in detail, the control applications. So these type of applications includes control and automation applications. And by doing that, most of the times what do we control the velocity or position of some object, right? Like you can control the position of a valve in water level indicator by doing automation with the use of signal and systems. You can control the speed of the induction motor, or you can control the position of the shaft of any kind of motor, right? So these are the control application. You can also use the drones, unmanned aerial vehicles, or unmanned ground vehicles as well, for that matter, self-driving cars. So we can use control systems and particularly signals and system in that domain. The important tools which we required for the control application of signals and systems are basically the time domain solution of differential equations, the transfer function, and stability. So you can understand it when you study the control system engineering in detail. And believe me, the control system is very vast topic, and you can get lost in it, but you will not find end of it. It's very vast. Then we have the communication applications. So these type of communication applications includes the transmission of information or data with the help of signal over the channel. Channel can be anything. Channel can be free space channel, can be coaxial cable, it can be fiber optical cable, or it can be anything. The key component of transmission of communication application is modulation. And modulation can be of two types. It can be either analog modulation or it can be digital modulation. And we are all well aware of analog modulation types, right? We all know what are the types of analog modulations. It is basically amplitude modulation, frequency modulation, right? And digital modulations, we use digital modulation in the applications of phone services, phone lines, computer modems, CDs. In the past times, we used to use CDs. In that, digital modulation used to was used. And there are so many advantages of this digital modulation as well, right? You can encrypt your signal with the help of digital modulation. Then the routing of data becomes very easier if you are using digital modulation. Then you can store that digital data very fastly. You can store so many amount of data in very small amount of time. And it can give you the multimedia capability to the system. You can play tape recorder on your vehicle, right? How is it happening? Because communication. Then there are signal processing applications. So basically, what is signal processing? So it is basically these applications are basically the applications of algorithms or to modify signals in a way that you can make them use the way you want. And the basic goal of signal processing applications are first to have the efficient and reliable transmission, to have efficient and reliable storage and display of the whole information. And second is to perform information extraction and enhancement of your extracted data. Now, what are some examples of signal processing applications? So, as I pointed earlier, we have speech and audio processing, we have multimedia processing, basically image processing and video processing, we have underwater acoustics, we have biological signal analysis, right? These are main streams that I'm pointing out. There are so many different applications of signal processing, and it is subject in its own, right? Then we have audio signal processing. So the application of the signal and system in the field of audio signal processing are like noise cancellation, digital audio effects, audio signal separations. So basically, in noise cancellation, you all may have heard about it, or you are using one of the headsets which allows you to cancel the outer noise. So it makes use of adaptive filtering principles and used in the earphones or headphones, right? Even the latest earbuds of Apple, they come with noise cancellation feature. But back in the day, do you know it was used to be used in the airplane cockpits to cancel out any other noise. Then you have digital audio effects, which is basically if you are a someone who is into the image processing things, or if you even edit some of the videos for YouTube, then you may know that you can use this digital audio effects to add special music effects such as delay, echo, reverb to your audio signal, which is played on the audio system. Then you have audio signal separation, which is basically used to separate my speech from the interference, right? Sometimes what happens, I'm speaking in the mic, you may hear my voice, but you may hear there is some other disturbance as I'm speaking. So if I want to separate both of these things, I use this feature, audio signal separation. I can even separate the sound of the wind which is coming from the back while I'm speaking, or even while I'm listening to the music in the car. I can cut out the noise which is generated by the wind. So these are the major applications of signals and systems. Then I want to discuss about the communication systems in detail first. So, and the reason I want to discuss about is uh, this is something you use in your day-to-day life. You use it in almost every day, and some of you may will not be aware of it. So basically, there are three three pillars of communication system. First is transmitter, channel is the second one, and third one is the receiver. And transmission and receiver are normally located far away from each other, and the channel is the medium. Physical, it can be physical medium, it can be non-physical medium. It can connect my transmitter with receiver, but you can view each of these pillars or blocks separately as well, as the separate system on its own as well. So the transmitter, what does it do? It converts my message or my signal at its input into a signal which is suitable for transmission. Then the message signal can be my speech signal, voice signal, video signal, computer data, it can be anything. What channels are possible to use? It can be any wired channels like coaxial cables, optical fiber cables, satellite channels, or we can use uh, channels like mobile radio channel, right? Which depends on the selection of channel depends on the area of your application. Now when the transmitted signal from the transmitter travels over the channel to receiver, it gets distorted because of the physical characteristics of the channel, and the noise will get generated, right? Other interferences will also get generated, and the received signal will be the corrupt version of my original transmitted signal. So the receiver will work on it in order to reconstruct it and estimate and it will get the estimate of your original signal. So the role of the receiver is to uh, filter it out, like, right, it is somewhat opposite of what was the role of transmitter. And all the functions which are performed by transmitter receiver, they are dependent on what type of communication system you are considering, right? But the basic knowledge is that you are sending signal using transmitter, receiving the signal using receiver. Now there are two different types of channels which we can use for the communication. It can be analog communication system, or it can be digital communications system. Let's discuss about the first one. The analog communication system is very basic, very simple. The transmitter has a modulator, receiver has a demodulator. Now transmitter does the modulation. What is modulation? Modulation is basically a process which converts my message signal into the form that will be compatible with the transmission characteristics of my channel. So the different types of analog modulations we all are aware of. I talked about it a minute ago: amplitude modulation, frequency modulation, and phase modulations. So the the transmitter uses one of these, and receiver has in to the part of the receiver we have to use appropriate demodulator at the receiving end in order to recover my original signal as it was sent by transmitter, right? Now let's come to the digital communication system, which is little bit complex compared to analog communication system, but uh, it has more advantages compared to analog communication system. So the message signal at the transmitter input can be either analog signal, like any kind of speech or any type of video, image, or any kind of digital signal like a computer data. So if the message is an analog signal, then the transmitter will perform whatever process we already know, are aware of, right? It will perform sampling, it will then do quantization and then encoding. But one thing to discuss here, that sampling and encoding are reversible processes. You can reverse the sampling process and encoding process, but quantization cannot be reversed. Remember, I told you when we discussed about quantization cannot be reversed because it is a process of approximating the sampled signals, right? So you cannot reverse it, and it also introduces some errors because of approximation. So what is the solution? What do we do? So that we are going to discuss about. That was for analog. Now for the digital. So digital message signals, what happens in that the sampling, quantization, encoding is not used at all, right? We basically use the signal as it was earlier in its original form. So the transmitter have to perform some additional operation like data compression, channel encoding, etc. Then the coded signal at the output of the encoder is used for modulation purposes, right? It can be a higher frequency, higher magnitude, higher phase with the help of carrier wave and whatever technique of modulation you use. Then receiver performs all these operations in the receiving manner in order to recover my original signal back, right? So it has to perform all these operations performed by my transmitter signal in the reverse process. Now in order to communicate, you need some channel and you need some mode of communication, right? So what are different modes of communication? There are basically two modes of communication. First one is broadcasting, second one is point to point communication. Now let's discuss about both of them in detail. First one, broadcasting. So basically you all have seen television sets, right? What is television set? That is broadcasting. If you have Wi-Fi or router on your in your home, what is it? It is example of broadcasting. So here a transmitter travels the information in many directions, and it sends out the information to different receivers, and it does it all that at the same time. So as you can see in this image, that broadcasting is the flow of information, con- uh, unidirectional information flow, right? It is carrying the unidirectional information flow, which means it only transmits from transmitter to receiver. The reverse is not possible, right? Because see, in television set, you cannot reply someone back. It's only one way transmission, just like broadband as well, one way transmission, right? Radio, that is one way transmission. So all that is called broadcasting. Radio is also broadcasting, one of the oldest broadcasting techniques. And the second one is known as the point to point communication. And what happens in point to point communication is the communication takes place between a single transmitter and the single receiver. As you can see here, I'm having one transmitter receiver pair on the left side and another transmitter receiver pair on the other side. The communication is taking place between two of them only, right? Both the sides of point to point link have a transmitter, a receiver, and the flow of the information will be bidirectional. It would be like two-way communication. So what are the examples of this two-way communication or point to point communication? So telephone systems, of course. Whenever you talk with someone in the telephone, that is two-way communication. Then what is other ways? Walkie talkies. Then the communication which takes place between my earth station and the spacecraft in the space, that is also two-way communication, right? We don't use telephone for that. But using both of these techniques, there are some problems associated with this, and there will always be while we're speaking of communication, because every communication system has to deal with the presence of channel noise, and this noise degrades the quality of the received signal completely, like it completely destroys if it is in too much quantity. But we can overcome this problem with the use of large antennas and with the help of error controlling techniques, right? In the earlier time, if you are aware of that, for the radios we used to have large antennas, and we used to say that the longer the nip of the antenna will be, the greater the channel will be, the clearer the sound will be. So we used to keep the nip of the antenna always sharpened up, always long, so that we can get better sound. We can listen the songs more in more appropriate way. Then I want to discuss about some of the control applications of signals and systems. So the control of the physical system is very important application of signal and system, right? So where do we use that control? So we use the signal and system to control machine tools. We use for the control of power plants. Remember I've told you about changing valve, so we can use it in power plants. We can use it in autopilots. I told you about unmanned aerial vehicles and self-driving cars. Nuclear reactors, in order to in order to uh, control its operation in more better way. Mass transit vehicles like your buses or trams, railways. We use it in robots in order to program robots for different operations. We use it in paper mills in order to produce paper in large quantities. Automobile engines, your bike engine, car engine, truck engine, all other type of engines, we use signal and system for the control application of these things. And the object that we are controlling is called plant. And why do we want to control it? So first we want to attain the satisfactory response of my plant, and second I want to improve the performance of my plant, right? Why do I use the signal system on my robot? Because I want to improve its performance. I want him to walk on a straight line. If it is not walking, it is if it is wobbling, then what I will do, I will try to update it. I will try to improve its performance, right? So we can describe the response to be satisfactory response if plant's output follows the track of a specified reference value, and the plant output should be maintained close to this reference value, right? And this process is known as regulation process. And if you are a electrical engineering student, you may have heard about the term voltage regulation. So basically that is the one type of regulation as well. And the control system with the best regulation is known as the robust control system, and that is not a new thing to all of us. We all are pretty much aware of it, right? Then there is a system known as feedback control system, which I want to discuss about. So we can attain whatever the desirable property we want to attain with the help of these feedback control system. In control system, if you have studied that subject, you may have heard about open loop control and closed loop control systems. In open loop control system, the feedback used to be absent. In the closed loop control system, the feedback is always present. So this is the closed loop control system in which we are having a feedback. Feedback can be of two types. It can be positive, it can be negative. And the plant which we are using, it can be described by the help of mathematical model, right? Which is producing some of the output. In this case, what is the output? It is y of t. And in the response of my input of the plant, what is the input of plant? It is control voltage, c of t, right? And there is an addition of some external disturbance, which is V of t. Then in the feedback path we use sensors. Of course we need to use sensors, right? If I want to let's talk about BLDC motor. If I want to sense the speed of the motor, and then accordingly I want my motor to operate on some other speed, and in order to operate it on some other speed I need to exert its voltage. So how would I know what is the position of my rotor? I have to use the hall sensors, right? So just like BLDC motor, you will be using so many different sensors according to different applications, and you will use it in the feedback path. So they can convert and the plant output Y of t into the feedback signal R of t, which is generally an electrical signal. Then the feedback signal is compared with the reference signal, my original signal X of t, and the error signal E of t, right? This is my reference input, so X of t. Here I'm getting a feedback signal, both of them are getting compared, and error is getting generated, and this error is then applied to the controller, which generates the control voltage C of t, right? E of t is basically the difference between X of t and R of t, difference between both of these signals. And then the control voltage C of t will control my plant. Now this control system can be of different types. There are system called CISO system, single input single output system, and the system which you are seeing currently is a CISO system. It is a single input single output. We are only giving one input, we are only getting one output. Then there is a system known as MIMO system, multiple input multiple output system. So it is a system which has multiple inputs and will have multiple outputs. And just like that, we have multi-user MIMO, which is used for the 4G connection networks of your phones. In that, we are having multiple users of multiple input, multiple output. That is 4G connection. And recently, the latest technology which we are using, 5G technology, that is using massive MIMO networks, which will have massive MIMO. That is a topic for some other class. Then there are systems known as digital control systems. Basically, your digital computers or microprocessors, microcontrollers. These systems are known as digital control systems. And as you all may have noticed it, these systems are becoming very much popular, and a lot of people and a lot of applications are using these techniques, digital control system, the microprocessors. Why? Because first, they are very flexible, and the accuracy of microcontrollers is very high. That is why it is widely used, right? And the digital control system uses the operation like sampling, quantization, and coding, like we stated earlier as well. So that was your feedback control system, and I think that was the wrap for today's class, in which we have discussed about sampling and reconstruction, and that is also wrap for this whole chapter. So next time we meet, we will be discussing applications of control system, applications of signals and systems based on Internet of Things. So if you guys have any doubts, queries, questions related to this class or any other class, please feel free to mention your doubts in the comment section below. If you have any feedback for this channel or the videos, if you are liking the videos, if you are not liking the videos, if the voice is not too good, if uh, if you want me to record my videos in some other languages, then please ask. I will try to I will try to reply to as many and as much as possible people, and as soon as I can. So I will be seeing you next time. Thank you very much for listening. Don't forget to leave a like and give a feedback. And until then, take care of yourselves. Thank you very much for listening, and goodbye for now. I will be seeing you next time with new chapter.